Both primary amines and secondary amines can form intermolecular hydrogen bond between their molecules, but for the tertiary amines, it cannot form hydrogen bond to each other. It only can form a van der Waals forces, which is a dipole-dipole forces between its molecule. Since primary and secondary amines, alcohols, and carboxylic acid, all of these compounds can form intermolecular hydrogen bond between their molecules, but alcohols and carboxylic acid have higher boiling point than primary and secondary amines. This is because the hydrogen bond in primary and secondary amines is between hydrogen and nitrogen atom, while in alcohols and carboxylic acid, the hydrogen bond is between hydrogen and oxygen atom. Since oxygen is more electronegative than nitrogen atom, the hydrogen bond in alcohols and carboxylic acid are stronger than in primary and secondary amines. That's why alcohols and carboxylic acid will have higher boiling point than primary and secondary amines. If you look at here, okay, we have one propanamine, one propanol, and ethanoic acid. The molecular weight of these three compounds are comparable. Okay, so they are the comparable size, but then the boiling point of alcohol and carboxylic acid is higher than our primary amine, which is our one propanamine here. Okay, so this is because oxygen is more electronegative than nitrogen. That's why the hydrogen bond in alcohol and carboxylic acid are stronger than in amines, our primary amines. Okay, but if we compare the boiling point of alcohol and carboxylic acid, so we already discussed about it in previous chapter. Okay, the physical properties of carboxylic acid. So carboxylic acid we have higher boiling point than alcohol because it can form a stable dimer. So we know that the molecules that are in stable dimers are arranged in closely packed. So the hydrogen bond in carboxylic acid are relatively stronger than in alcohol. The boiling point of primary amines is higher than secondary amines because primary amines can form more hydrogen bond between its molecule compared to secondary amines. As the number of hydrogen bond increases, the stronger the hydrogen bond. So that's why primary amines have higher boiling point than secondary amines. For example here, if we have one propanamine, the primary amines, and N-methyl ethanamine, secondary amines, the molecular weight are comparable, okay, same molecular weight, okay, but then the one propanamine, our primary amines have higher boiling point compared to secondary amines, okay, so this is due to the primary amines can form more hydrogen bond between its molecule. To compare the boiling point of alkanes, haloalkanes, carbonyl and tertiary amines with primary and secondary amines, alcohols and carboxylic acid, we need to identify its type of intermolecular forces. So alkanes is a nonpolar molecule, so it only can form a weak London force between its molecules, while haloalkanes, carbonyl, and tertiary amines are polar molecules, so it can form a dipole-dipole between their molecules. Primary, secondary amines, alcohols, and carboxylic acid, all of these can form intermolecular hydrogen bond between their molecules. So since the van der Waals force, okay, these two are van der Waals force, is weaker than the hydrogen bond if the molecular weight are comparable, okay, primary, secondary amines, alcohols, and carboxylic acid will have higher boiling points than alkanes, haloalkanes, carbonyl, and tertiary amines. Right, so these are an example of alkanes, haloalkanes, primary amines, alcohol, and carboxylic acid. Okay, all of these have uh, comparable molecular weight. Okay, as you can see, alkanes have the lowest boiling point. Okay, sebab dia adalah non-polar molecule, so it only has a London force between its molecule. Okay, compared to haloalkanes, so haloalkanes is a it's a polar molecule, so it has a dipole-dipole. So if the molecular weight are comparable, dipole-dipole has higher volume, has stronger intermolecular forces compared to London force. Okay, for the primary amines, alcohols and carboxylic acid. So all of these have intermolecular hydrogen bond between their molecules, so it will have higher boiling point compared to the one with van der Waals force. So if we compare the boiling point of primary, secondary, and tertiary amines that have same molecular weight, okay, so primary amines we have the highest boiling point because it can form more hydrogen bond between its molecule, okay, compared to secondary amines. So these two can form intermolecular hydrogen bond between its molecule, but then primary has highest one because it can form more hydrogen bond. Okay, so as the number of hydrogen bond increases, the stronger the hydrogen bond. Okay, but then for the tertiary amines, since it's only have a dipole, okay, a van der Waals force, so van der Waals forces is weaker than hydrogen bond, so that's why it has lower boiling point compared to primary and secondary amines. Alkenes is a nonpolar molecule and it has a London force between their molecules, while haloalkanes, carbonyl, and tertiary amines are a polar molecules and it have dipole-dipole forces between their molecules. Dipole-dipole is stronger than London force if the molecular weight are comparable. Thus, haloalkanes, carbonyl, and tertiary amines will have higher boiling point than alkenes. As you can see here, butane and trimethylamine have comparable molecular weight, but trimethylamine will have higher boiling point than butane because tertiary amines, which is our trimethylamine, it is a tertiary amines, will form dipole-dipole force while alkene only can form London force between its molecule. So dipole-dipole force is stronger than London force if the molecular weight are comparable. Next, let's compare the boiling point of amines if it got different molecular weight. So we know that molecules with bigger molecular weight will have larger surface area and stronger intermolecular van der Waals forces will exist between the molecules. More energy is needed to overcome the forces. That's why boiling point is higher. So if we have an ethanamine, okay, with 45 gram per mole molecular weight, and one propanamine with 59 gram per mole molecular weight. So, since one propanamine have bigger molecular weight than ethanamine, so it will have higher boiling point compared to ethanamine. So, in this case, kita tak discuss about the strength of the hydrogen bond because both are primary amines, okay, both can form more hydrogen bond with their molecules, okay, but then the difference here is the number of carbon, okay, the alkyl group. Alright, so kita fokus kepada the strength of the van der Waals. So that's why we are going to discuss about the strength of the van der Waals force. Let's do some example. Arrange the following compounds in increasing order of boiling point. Explain your answer. So we have the IUPAC name of the compound. Okay, since kita hanya ada IUPAC name sahaja, so first thing first we have to draw the structure. Okay, from the structure of the compound, so kita boleh calculate its molecular weight. Okay, so kita draw dulu. Alright, so first here we have one propylamine. Okay, so kita ada propyl, 3 carbon, CH2, CH2, CH3 attached to the amino group. Okay, the amino group is placed on the first carbon. Alright, and then we have N-methyl ethanamine. So ethanamine is the longest carbon chain, ada 2 carbon, 1, 2. Okay, N-methyl means that we have a methyl group attached to the nitrogen. Alright, so here is N-methyl ethanamine. Okay, and then we have N-dimethyl methanamine. So the longest carbon chain is 1. Okay, so sebenarnya kat sini kita boleh cakap trimethylamine. Okay, pun boleh. Okay, so kita ada 3 methyl group attached to the nitrogen. And then we have 1 propanol. So 1 propanol means that 3 carbon. And then the OH group is attached to the first carbon. 1, 2, 3 carbon. And then last but not least, the ethanoic acid. So 2 carbon, C double bond O, OH. So the molecular weight of this compound. Okay, kita kira dulu dia punya molecular weight. Alright, so as you can see, all the compounds, okay, kita ada 5 compounds ni, kelima-limanya have a comparable size, okay, tak jauh beza dia punya molecular weight, so we said that it have a comparable size. And then next, let's identify its type of intermolecular force for each compound. Okay, for the first compound here, we have a primary amine, so we know that it has a hydrogen bond. It can form hydrogen bond between its molecule. So it will have a London force, dipole-dipole and hydrogen bond, tapi yang paling dominant adalah the hydrogen bond. Same goes to the secondary amines. Okay, kita ada London force, dipole-dipole and also hydrogen bond. This one is a tertiary amine, so we only have a London force and dipole-dipole since dia adalah polar molecule, but then it cannot form hydrogen bond with its molecule, so that's why dia ada London force dengan dipole-dipole saja. Alcohol and carboxylic acid, okay, so both will have London force, dipole-dipole and hydrogen bond. So to arrange in order of increasing boiling point, okay, the one with only van der Waals forces, so kita tahu kalau size dia comparable, the van der Waals force is weaker than the hydrogen bond. So our tertiary amines here will have the lowest boiling point. Okay, so let's label our tertiary amines here as a compound A. So kita label dia sebagai A, right? So we have A here, right? And then, okay, between amines and alcohol and carboxylic acid, since nitrogen, okay, dengan oxygen is more electronegative, so the amines will have lower boiling point compared to alcohol and carboxylic acid. So antara primary and secondary amines, since primary amines can form more hydrogen bond compared to secondary amines, so this one, our secondary amines here will become compound B. Kita susun dia sebagai B. And then tertiary amines will become C. Alright, and then C. And then between alcohols and carboxylic acid will have highest boiling point. Okay, dia akan ada higher boiling point than alcohol because it can form a stable dimers. Okay, so alcohol akan jadi compound D. Okay, so we have D, and carboxylic acid will become my compound E. Alright. So kita labelkan sebab nak tulis nama dia dalam explanation panjang sangat. So kita boleh just label like this. Okay, so put the arrows. Okay, so kita letakkan arrows and then tuliskan increasing boiling point. Okay, so since kita susun ni tadi, okay, sebenarnya kita dah tahu dah kenapa kita susun dia macam ni. Okay, so that is what we are going to put in our explanation. Okay, so to explain it into sentence, first, we state that compound A, B, C, D, and E have comparable molecular weight. Okay, so why compound A has the lowest boiling point? Because it can only form a weak van der Waals forces between its molecule, which is a dipole-dipole, while B, C, D, and E will form hydrogen bonding between their molecules. So since hydrogen bond is stronger than dipole-dipole, that's why A has the lowest boiling point. Compound B, C, D, and E all can form hydrogen bonding between their molecules, but since oxygen is more electronegative than nitrogen atom, the hydrogen bond in compound D and E are much stronger than compound B and C. The boiling point of compound B is less than compound C because C is a primary amine while B is a secondary amine. Since primary amine can form more hydrogen bonding between its molecules compared to secondary amines, as the number of hydrogen bond increases, we know that the strength of the hydrogen bond also increases. Last but not least, the boiling point of compound D is lower than E because E can form a stable dimers through the hydrogen bonding. So molecules in dimers are arranged closely packed, thus the hydrogen bond in compound E is relatively stronger than compound D.